Here's an example of a polynomial, 6x to the 5th minus 7x squared plus 4. Now, a monomial is a specific kind of polynomial. It's a polynomial with just one term. So if we had just 6x to the 5th, a single term with a coefficient times a variable to a power, that's an example of a monomial. And negative 7x squared would be another example of a monomial. And the same goes for the number 4 by itself. So next, take a look at these expressions down here. Which are monomials? Exactly, the number 6 by itself, negative 3x, and 9x to the 8th are all monomials. So now let's take two monomials, like x to the 5th and x to the 3rd, and let's multiply them together. X to the 5th times x to the 3rd equals x raised to another power. What's the missing exponent here? And click here if you'd like to review. Right, whenever you multiply powers with the same base, you can add the exponents. So x to the 5th times x to the 3rd equals x to the 8th. In general, whenever you're multiplying monomials with the same variable, like 4x squared times negative 3x to the 5th, you can add the exponents and multiply the coefficients. So to simplify this product, you can look at the powers, x squared and x to the 5th, and their product is x to the 7th. Then you can look at the coefficients, 4 and negative 3, and their product is negative 12. So 4x squared times negative 3x to the 5th equals negative 12x to the 7th. Next, try finding this product, 7x cubed times 2x to the 6th. Nicely done. X cubed times x to the 6th is x to the 9th, and 7 times 2 is 14. So this product is 14x to the 9th. Next, suppose you have a monomial like x to the 7th, and now you're dividing it by another monomial with the same variable, like x to the 3rd. This quotient equals x raised to some power. What's the missing exponent here? Right, when you divide powers, you can subtract the exponents. So x to the 7th divided by x cubed equals x to the 4th. So whenever you're dividing monomials with the same variable, like 8x to the 9th divided by 3x to the 5th, you can subtract the exponents and divide the coefficients. So for this example, x to the 9th divided by x to the 5th equals x to the 4th. And 8 divided by 3, well, we can just leave that as the fraction 8/3. So here's the simplified quotient. So next, try simplifying this quotient, 6x to the 7th divided by 2x. Excellent, so 2x is the same thing as 2x to the 1st, so this quotient equals 3x to the 6th. Next, try simplifying this quotient, 12x squared divided by 6x to the 7th. Now the denominator has the larger exponent. Right, so there are a few ways you could have answered this. This equals 2 over x to the 5th, which is the same thing as 2x to the negative 5th, a negative exponent. So, for your next challenge, suppose you have 9x to the 5th, and you're multiplying that by 2x to the 6th, and then you're dividing this product by 6x to the 7th. Try simplifying this expression, and if you get stuck, click over here and we'll figure this out together. Excellent work! 9x to the 5th times 2x to the 6th equals 18x to the 11th, and then 18x to the 11th divided by 6x to the 7th equals 3x to the 4th. Now one more thing. So far we've been looking at monomials with the same variable. But suppose you're multiplying a monomial with one variable, like 4x cubed, by a monomial with a different variable, like 2y to the 5th. Well, the rules about combining powers only work when the powers have the same base. So how would you simplify this expression? Well, you can multiply the coefficients, 4 and 2, to get 8. Then you just write x to the 3rd and y to the 5th. So this product is 8x to the 3rd, y to the 5th. Not too exciting, but that's the best you can do with variables that are different. So how might you simplify an expression like 6a squared over 3b to the 7th? To get started, go ahead and multiply these two monomials, 3x to the 5th times 4x squared, or click down here to review. Right, this product is 12x to the 7th. So great, you know how to multiply monomials. In this lesson, we'll be multiplying binomials. A binomial is a polynomial with exactly two terms. So take a look at these polynomials down here. Which of these are binomials? Precisely, each of these polynomials has exactly two terms. This polynomial has one term, so it's a monomial, and this polynomial has three terms, so it's called a trinomial. Next, let's quickly review the distributive law. If you add two numbers inside parentheses and then multiply by another number, you can distribute the multiplication onto the addition. So which of these expressions is equivalent to 4 times 8 plus 3 in parentheses? Exactly, 4 times 8 plus 3 in parentheses is equal to 4 times 8 plus 4 times 3. And remember, you can also distribute multiplication onto subtraction. So 4 times 8 minus 3 equals 4 times 8 minus 4 times 3. Now the distributive law also works when you have variables instead of numbers. So for example, if you have x times y plus z in parentheses, you can distribute the x, and this equals x times y plus x times z. So try using the distributive law to simplify this expression, x squared times x cubed plus x to the fifth in parentheses. So there should be no parentheses in your final answer. Right, you distributed the x squared. X squared times x cubed is x to the fifth, and x squared times x to the fifth is x to the seventh. So this product equals x to the fifth plus x to the seventh. Try another example. What's 2x times 3x plus 4? Nicely done. This equals 6x squared plus 8x. So now you've got some practice multiplying monomials and binomials. Next, let's look at multiplying two binomials together. Here's an example. A plus b times c plus d. How can we simplify this expression? The trick here is to think of a plus b as a single term and to distribute it onto c plus d. So if you perform this distribution, which of these expressions do you get? Precisely, so a plus b times c plus d equals this expression here. Now take a look at the first part of this expression. You're multiplying c by a plus b in parentheses. So you can distribute the c onto the a and the b. And over here, you can distribute the d onto the a and the b as well. So after performing both of these distributions, what expression do you get? Excellent. So a plus b times c plus d equals this expression here. Since we're adding all these terms together, we can switch the order of the terms. Now you might have noticed that each of these terms contains a variable from the first binomial and a variable from the second binomial. In fact, over here we have the first terms from each binomial, and over here we have the outside terms, that is, the two outermost terms. Here we have the inside terms, meaning the two innermost terms, and here we have the last terms of each binomial. And this is a great way to remember how to multiply binomials, F-O-I-L, or FOIL. When multiplying binomials, be sure to multiply the first terms, the outside terms, the inside terms, and the last terms, and then add up those four products. So try using FOIL to expand this product, 2x plus 5 times 3x plus 1. And by expand, we mean write it out as a single polynomial with no parentheses. And if you need some help, click over here. Excellent work! Multiplying the first terms, you got 6x squared. The outside terms gave you 2x. The inside terms multiply to 15x, and the last terms multiply to 5. And you recognized that you have two like terms here, 2x and 15x, which add up to 17x. Plugging that in, we have our final answer. 2x plus 5 times 3x plus 1 equals 6x squared plus 17x plus 5. Let's try another example. X minus 4 times 2x minus 3. And notice that this time we have minus signs. Now x minus 4 is the same thing as x plus negative 4. So the second term in this binomial is really negative 4. And the second term in this binomial is negative 3. So keeping these negatives in mind, try using FOIL to expand this expression. Be sure to combine any like terms you get, and feel free to ask for a hint if you need one. Excellent! The first terms give you 2x squared, the outside terms give you negative 3x, the inside terms give you negative 8x, and the last terms give you positive 12, since you're multiplying these two negatives together. And you had two like terms. Subtracting 3x and then 8x is the same as subtracting 11x. So that's the answer. X minus 4 times 2x minus 3 equals 2x squared minus 11x plus 12. Okay, here's your final challenge. Suppose you have the binomial x plus 3 and you want to square it. You might want to distribute the exponent onto the addition, but remember, you can only distribute exponents onto multiplication and division. So how can we simplify this? Well, remember that squaring something means you're multiplying it by itself. So x plus 3 squared is x plus 3 times x plus 3. So you're multiplying two binomials here, and you can use FOIL again. So go ahead and use FOIL to expand this expression. And again, be sure to combine any like terms you get. Very well done! X plus 3 squared is the same thing as x plus 3 times x plus 3. Multiplying the first terms gives you x squared, the outside terms gives you 3x, the inside terms gives you another 3x, and the last terms gives you 9. Adding 3x and then another 3x is the same as adding 6x. So that's the answer. X plus 3 squared equals x squared plus 6x plus 9. Plug in any value for x, and these two expressions will always give you the same result. Multiplying binomials is one of the trickiest parts of algebra, but if you remember FOIL, first, outside, inside, last, and you're careful with your negatives, you'll get the right answer.